Hello and welcome back to Math with Mrs. Becker. Today in college algebra, we are going to study some properties of logarithms. We are looking at section 3.3 in the textbook. Now the first thing is you will run into some logs that the way that they are written, like here it's log base 4 of 25 and here it's log base 2 of 12. You cannot put these into a calculator. Yes, the calculator does have a log key, but this is what's called a common log, meaning it automatically has a base of 10. Well, neither of these two logs have a base of 10. Therefore, you can't just use the calculator. However, there's a property, and it's called the change of bases formula. Okay, so change of base. You can rewrite this in a format that does allow you to use the calculator. So first, we're going to look at common logs. Common log means that we have a base of 10. So what you can do is you rewrite it so it's a log base 10 of the larger number, okay, not the larger value, the larger written number. So it's log base 10 of 25 over log base 10 of whatever the base is. Now that they are log base 10, you don't even have to write the 10, so this is log of 25 over the log of 4. I can enter this into the calculator. So if I have log of, remember it opens a parenthesis, 25, close it. So the log of 25 divided by the log, it will open a parenthesis, put in the 4, close it. This would be 2.32 if I round it to the 100th. So what this means is 4 to the power of 2.32, or approximately this, would get you to 25. But we could not find this in the calculator without using the change of base formula. Let's look at one more. When they say common logs means that really you're doing a base of 10. And notice the formula. The big value, okay, when I'm looking at the size of the text, that goes on the top. The base goes on the bottom, and that's kind of how I always remembered it. Base and bottom, they both start with a B. Okay, so the base of the log is the value that goes on the bottom. Let's do another one. Log base 2 of 12. Change of base using common log, so it's log base 10 of 12 over log base 10 of 2. Because they're bases of 10, you don't have to show them. So this is actually the log of 12 over the log of 2. Now that they are common logs, now you can use the calculator. Log of 12 divided by log of 2. If I round it to the 100th, it's 3.58. So what this means is 2 to the power of 3.58 is approximately 12. Okay, this formula also works using natural logs. Remember, natural log is your ln. Now again, the reason why this works is because ln is on the calculator. So right now, it's the same two problems. I cannot put log base 4 of 25 into the calculator, but I can do the change of base formula, which means I'm rewriting it as a fraction, but I can do it as natural log of x, the larger written text value, b, the base is on the bottom. So it would look like this. Natural log of 25 over natural log of 4. Again, the base goes on the bottom. I can put this in the calculator. Natural log of 25 divided by natural log of 4 equals, and again, if I'm rounding it to the 100th, it's 2.32. Notice we got the same thing, whether we used a log or a natural log. Common log, natural log. You got the same exact value. Let's try it with the other example. I cannot put this into the calculator. They want me to do change base formula, which means write it as a fraction, natural logs. So it's the natural log of 12 over the natural log of the base, which is 2. You can enter that into the calculator. Natural log of 12 divided by natural log of 2. Again, if I round it to the 100th, I get 3.58. So this is the change of base formula. What it allows you to do is enter things into the calculator that otherwise you would not have been able to do. If you are ever asked to use the change of base formula, it is imperative that you show the fraction, because that's how you're showing that you use the change of base formula. So you do have to not only just write the result, but also show that formula. How did you write it as a fraction? Okay, next one. Now, these properties of logarithms, what they will allow us to do is condense and expand our expressions. What this shows us is that multiplication goes with addition. So if I'm multiplying two values, I can expand it by applying the log. Make sure that you keep the base the same. So I could take the log base a of u, because you're multiplying, plus log base a of v. So now the same thing I can condense. If this log is a base of a and this log is a base of a, I can condense it into one log with the base of a. Addition goes with multiplication, so I would just multiply the u and the v. Subtraction and division go together. So again, I could say if I have log base a of u divided by v, division goes with subtraction. So I could take the log base a of u minus, to indicate that it's actually division, log base a of v. So that would be expanding. I could also condense as long as the bases are the same. Log base a matches log base a, so I could write it as 1. Subtraction means you're dividing, so it'd be u divided by v. Another property is you cannot have an exponent on a logarithm. Your exponent has to go out front. Okay, and again, this can go either way. When you're trying to expand or when you're trying to condense, you have to be comfortable with taking an exponent moving out front, or if you're condensing, saying, okay, there's a value out front, I can send it back as an exponent. Okay, let's go ahead and use some of these properties. Now, this is where I kind of like it. It's fun. We have a natural log of 6. They want us to rewrite this using the properties and only using 2's and 3's. So what I have to realize here is that I can create 6 using the number 2 and 3 by multiplying. So 6 is 2 times 3. So I did not change the value at all. I just wrote 6 in a different format. Now multiplication goes with addition. So I can have the natural log of 2. Because I'm multiplying, I would add the natural log of 3. Done. Kind of fun. Now here again, natural log of 2 over 27. Now this is a 2. I need to turn 27 into just 2's and 3's. So here I have natural log of 2 is fine. 27 is 3 cubed. 3 times 3 times 3. So now I'm going to expand this. I have the natural log of 2. Division, so it's minus. Now it's the natural log of whatever's on the bottom, 3 cubed. But I cannot have an exponent on a log, even if it's a natural log. So this exponent has to go out front. So your final answer is the natural log of 2 minus 3 times the natural log of 3. So we rewrote these using properties where our final answer only contained natural log of 2 and natural log of 3. Okay, now here's a skill. Hopefully you remember at least a little bit of this from Algebra 2, where we can expand logarithm expressions. Now notice this is a cluster. So what this means is that we are multiplying everything. Multiplication goes with addition. You just have to make sure that you maintain that base. So what this would look like is log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. So right now I separated it. The only thing is that this is an exponent. This exponent has to go out front. So I have log base 4 of 5 plus the 3 comes out front, log base 4 of x plus log base 4 of y. This is expanding it, using the properties, expanding it as much as you possibly can. Okay, here is another one. Natural log. Remember, if you ever have a square root is the same as an exponent of 1/2. So this is the same thing as 3x minus 5 to the 1/2 power over 7. Okay, these two things are equivalent. Now when you're doing this, this is a little bit tricky because this 1/2 applies to this whole section. So what happens is I have the natural log of 3x minus 5 to the 1/2 minus, because it's division, the natural log of 7. Last step, if you have an exponent, bring it out front. So your 1/2 goes out front of the natural log of x minus 5 minus the natural log of 7, and we're done. Okay, so there they were testing you. Do you remember that a square root is the same as an exponent of 1/2? All right, couple more. Now we're just going to go in reverse. So now we are going to condense. If you are condensing, that means at the end, your problem can only have one log. This is a log with a base of 10. This is a log with a base of 10. So my final answer, I can only have one log with a base of 10. If you have a number out front, this is really an exponent. This is also really an exponent. Okay, so if I'm just kind of figuring out what's going on, this is x to the 1/2 plus this is a log base 10. This is x plus 1 to the power of 3. I'm adding, so I know that we're actually multiplying. An exponent of 1/2 means a square root. So what I have is a log base 10 of the square root of x times x plus 1 cubed. Done. Adding means we're multiplying, so I put them side by side. They both had a log base 10. When you condense, you only get 1. If you would have kept it as log base 10 of x to the 1/2 times x plus 1 to the power of 3, I would have taken this as well. It's one step further to realize that this exponent of 1/2 is really a square root. Either of these answers would have been sufficient. Okay, now let's go ahead and look at a natural log. If you have a number up front, it's actually an exponent. So this is really natural log of x plus 2 to the power of 2 minus the natural log of x. Both of these are natural logs, so if I'm condensing, I get one natural log at the end. X plus 2 squared minus, so I'm dividing by x. Done. Just condensing. Okay, here's the next one. Whoa, this 1/3 goes to the whole thing. So I need to simplify the inside first and take the whole inside to the power of 1/3. This is a log base 2. This is a log base 2. So I write it as one log with the base of 2. Adding goes with multiplying. So I'm multiplying x times x minus 4. This whole thing has an exponent of 1/3, which is a cubic root. Okay, so those are the properties of logarithms. Notice that at times we use natural logs, at times we use common logs, at times we use logs with a base other than 10. The properties hold true for all of those things. Okay, for your assignment today, there is a suggested assignment. Okay, there's 46 questions. It sounds like a lot, but you guys, it goes super fast. But if you're worried that you may struggle with condensing or expanding or using that change of base formula, I do highly recommend that you even just try some of them just to go ahead and make sure that you're comfortable. What your assignment is just a quick quiz. Okay, so let's go ahead and look at this. If you're doing a quick quiz, if it asks you for the change of base formula, that means number 1, you do have to show the fraction. Then round your solution to the 100th. So these are each worth 2 points. Make sure you read the whole question. This says to do common logs. Okay, so you should have a fraction and a solution rounded to the 100th. Same thing, change of base formula. Make sure you have a fraction. They're saying use natural logs, so ln, and then your final answer round to the 100th. So again, each of those are worth 2 points. Now condense. Condense to a single log. So you're going to take these, write it as 1, and then here you're expanding. And this is the only thing that you will go ahead and turn in for the day. I hope you guys had a great time talking about logarithm properties, and I'll talk to you soon.